So, and the next one, what we have is lightning talks. I'm not going to lead the session, but I'm going to pick two first speakers. And I don't know the rules, but I give you the hint that we're going to use the dice. So I need the bell, I guess. Can you bring it up?
Can I interrupt with one short announcement, which is urgent? Sure. Yeah. Sorry for the interruption. So if you're on the waiting list for a social event, you should definitely check your emails. Because, and if you don't, and everybody who does not pick up a ticket, because we have 20 more tickets, so waiting list first, and everything that remains after that is going to go on public sale in 15 minutes. Thank you.
Okay, and the first speaker is Valerio. And the second one is Marco Garrelli.
Is in the room?
Marco?
Yes. Can you please come here to the legislator? Thank you.
So,
Did you pick up my name?
Yep.
What are the chances?
Yep.
Very random.
Who could thought about this, right?
Yes.
And I guess we need to roll those. Does anyone have the dice so we can roll?
Yes, we have it.
Okay.
Cool. Can I plug my computer?
So it's.
Ooh, nice. Who knows? First rule of lighting. Work. We're going to switch all computers now, so it should be fine. Spoilers. Right, so this very random talk I've been selected is about lighting talks at EuroSciPy. And so lighting talks this year is going to be slightly different than probably you're used to. And we're thinking lighting talks the Dungeons and Dragons way. By the way, this was an idea brought back from SciPy 2023, directly from EuroSciPy to EuroSciPy 2023. So public shout out to the people at SciPy this year who gave the idea and provided the die. So the lighting talks are going to be driven today by the three Fate sisters. Actually, 3 minus 1. The first is Lachesis the Allotter. We have the Allotter here. We're going to be very nerds today, sorry. We have the Allotter. We're going to use this one to randomly pick a name. As you might have noticed, we have first-timers and experienced speakers. What I'm going to talk about doesn't necessarily apply to first-time speakers. So if you're a first-time speaker, no worries. Nothing is going to happen to you. But if you're an experienced speaker, be ready. So I'm going to randomly pick names, and the same list is going to be kept for tomorrow. So if you're not talking today, you might have chances to talk tomorrow as well. Second sister, Clotho, the spinner. We have a dice. I'm going to explain how we're going to use it in a second. Well, the third sister is actually Atropos, which is indeed death. But we decided it's probably not properly to use it, so it's on vacation. We're not going to use death in the game. So if we're going to roll a 1, this is what's going to happen. Every time you mention magic word during your presentation, the audience is going to quack and have props. So I'm going to host it, and by the way, the person in charge of rolling the dice, Konstantin in particular, is going to wear the witch hat, and we have lots of props actually. And this is my signal to you to quack during the talk. Second, so for example, imagine the magic word is pizza, and I say, welcome to my talk, Python, pizza, and you quack. Okay, shall we try it again with a little bit of, enthusiasm a bit? It's a game, it's having fun. So let's say pizza is the magic word. Python, pizza, and pineapple, bang. Nice. Well done. If you roll a 3, by the way, we're going to work today with odd numbers, just because we're odds people. The 3 is glamorous broccoli. So, you have two options here. You can either wear these very fancy and glamorous glasses during your talk, like this, or you have to say broccoli during your talk. It's up to you. So for example, Napolitan pizza is my favorite kind of pizza. Thank you, well done. Very well done. Love you guys. Definitely not with broccoli because it's very forbidden. If you roll a 5, too hot to handle, you have to wear this amazing, thank you Sepide for providing it, oven gloves all the time. And you have to use it to change lights, so it's going to be fun. Especially if you're hands-on session, it's going to be fine. So you have to do the talk this way. And I'm going to try this. I haven't, to be honest. So it does work. If you roll a 2, a 4, a 6, narrow escape, you're safe for today. So this is the game. Have fun. Be nice in a very chaotic, neutral way. And be free. If you don't want to play, it's very fine. You just say it. There's no problem. But still in the chaotic, neutral way. Come on. Tomorrow may be different. So, who's next? Get ready. Yeah, get ready with a witch hat.
Oh, I'm picking the name.
Yes, no, I'm picking the name, you roll the die.
Oh, okay. And I also made
So,
it, right?
yes.
Let's start
Sorry.
connecting.
Yes, let's plug in. In the meantime, I just like...
So,
Do you want to play?
Do I want to play?
you're still safe.
The next one you're going to have... two probably. Let's pick a first-time speaker. It's going to be Luca. Rust is easy. Luca Baggi. Rust is easy. Get ready for later. Take it away.
I've got a question. Am I allowed to say broccoli anyway?
You can.
All right. Well, that's marvelous luck. So, hello, everybody. I have a data frame that looks a bit like this, and I would like to map each number to a vegetable. How can I do that? So, one idea I have, one absolutely brilliant idea, is, whoops, didn't mean to print the page, this is why we don't do live coding, but I do it anyway, is to do something like this. pl.call data.apply lambda x my dict x, and now I'm just going to run it. Oh, wait, what's this? So apply is significantly slower than the native expressions API. Only use if you cannot implement your logic otherwise. In this case, you can replace your apply with the following. Okay, well, let's try that out. So let's copy that here. Let's copy and paste the suggestion. Let's, just paste it in there. Are the brackets lined up? I think so. And now the same thing takes just over half a second. So that's a 10x improvement, which Polar's just gave us for free. It tells us how we can write better code. But how does this work? It works with this magic. Import dis.get instructions, lambda x, my dict x. And if you look at this, so we just load the mydict variable, then we've got load fast, which is the argument of the lambda, and then a binary subscript operation. We pass this in postfix notation, and then can reconstruct the message that we give to the users, and we can also inspect the variables which are local to the caller to check that mydict actually is a dictionary. If you'd like to learn more about what magic pollers can do to you, then come to the lightning talk tomorrow morning. I think it's in the morning, but it is tomorrow. Thanks for your attention. Enjoy the rest of the lightning talks. I've been Marco.
To probably fix that, I need a microphone. Do I? Yes. Okay. So I'm gonna.
First time?
Luca is gonna come upstairs. Are you really first-time speaker? No. So you cheated. Okay, come on.
Okay, he's up to it. Okay.
Okay, good. Nice.
That's appreciated.
It's just you, actually. So let me. Yeah, of course, of course.
Okay, and who's this? You're picking up the next one for now. Right?
Yes.
Okay, who's gonna bring it up?
That's a 3.
Take it away. Next one, please. Come up stage. This is glued. Sorry, I'm gonna mispronounce your name because I can't read it. Is it a secret message? What the hell is this? Quite good. So, Mildred Seth, DuPy embed, don't do this, please no, maybe? Vadula here? Fantastic. Take it away.
Great. So, are we seeing any of this? Yeah, looks fine. Great. Okay. Yeah, I was talking about you, not about me. I mean, I think I can see it clearly. So, plot twist. First plot twist of today's. Can you hear me? Can you see me? Don't think so. Yeah. Let's make it a bit bigger. Even bottom rows. Great, good to know. So, first slide of today's, I won't be doing Rust is easy. I will actually be doing Python what the quack. Okay, because I've always been bugged by something, which was this very easy for loop thing. And it was like, okay, how many times have you done this? Lots of times, maybe not this easy, but kind of. This was something that we've always been accustomed to doing. And then if we print I, what happens? Well, you get a 4. I've always supposed that I goes out of scope, so I isn't nothing, right? So like, but feels odd to me. And then I got really into these Python oddities, and I would like to show you 5 of them, at least 5, maybe a bit less than 5. Starting with this one, actually. Say we have a statement that looks like what a quack, okay? And we would like to do something like this. Let's get back our for loop. And we say for I, some dict of I in enumerate statement. And then we just print I. What happens? Will you tell me? Well, of course, it's going to print I from 1 to 4, unless we didn't define this dictionary, which is supposed to be an empty dictionary, right? There we go. So let's go back. What happens here? Of course, we're going to print number from 1 to 3, actually from 0 to 2. But what happened to our dictionary? Can you guess it? Well, something changed. Things can change inside for loops, but also in the definition, during the definition of for loops, and through every pass of your for loop. So please be careful about using those. Okay, so this was the warm-up. Let's get back to something more easy, right? How many of you have used the Wallace operator? Yeah, I saw somebody, actually, Marco, created a pre-commit link that actually converts everything into, not everything, but performance matrix conversion into Wallace operators. And that's convenient, but also it's convenient that it doesn't change everything into Wallace operators, because they can be pretty weird, you know, at times. Because if you want to use them like so, for example, say a equals Wallace to 1, what happens? We get an error, of course, because this is an invalid syntax. Wallace operators are meant to be used inside parentheses. So this works, of course, fine, great, good. What happens if we mix it in with a bit of tuple unpacking, though? Let's just say we've always been used to do this. What happens if okay, of course, if we do this, we will get an error. We know it. But what happens if we do this? It printed a tuple. What happened to A? Well, it became 5. makes sense. The point is, Walrus operators happens inside the scope, so perform the assignment of 5 to A. So please be careful. If you wanted to do this for real, you should have used this notation. There we go. And so if you go A, now it works. And these are some kind of nice Python oddities, but be ready, strings are even worse. What happens if you say A is what a quack and B is what a quack? Well, of course, we know that if we compare A and B, they will be the same thing. If we just look at their memory address, they will be the same. What if, though, we change A to what a quack, exclamation mark, and we do the same with B? Of course, you know something is going to happen, so if we say A is B, of course it will be true, but if we change it to A is B, it will be false. What happens is these kind of objects are basically, I wouldn't say inline, but up until a certain number of characters, the memory address is basically the same and the strings are pointing to the same object in memory. When the string grow too big, they do not. And why so? Well, just imagine you're doing something like this character times, I don't know, e to 10 to the power of 10th. You cannot just have them share the same bits of memory. But this doesn't end up here, because if we do this, and if we say, what the fuck, what the quack, sorry, twice, and we say A is equal to B, of course it is, and if we now say A is B, what if we expect that it will happen? It will be true. Magic. Okay, this is crazy. And would you believe so that numbers behave pretty much in the same way? Because if we say A is equal to 256, okay, B is equal to 256, and then if you say A is equal to B, of course, I don't have to prove this, but if you say A is B, the address is the same in memory. But what if we change it to A is equal to 157, and B is 257? The magic. Gone.
Thank you.
Thank you.
You definitely look glamorous in that glasses.
Keep the glasses.
But do eat your broccolis, though.
Good. So I'm going to pick up a name. You're going to roll a die. It's difficult to handle all the things with 2 hands. I need another hand. See? This is done. That's it. Aha. So what the magic word is going to be? Jupiter? Okay. So let's get on stage. Afterwards, we have Marco Zamboni. What the heck? Researchers. Marco, are you here? Yeah. Can you go there, please? Okay, so I will advise you with this one. Get ready. Take it away.
All right, so this talk is about JupyPy embed, so there are some rules, like more rules that you're not allowed to judge me for the next 5 minutes, and you're not supposed to do this. You should not do this. Please don't do this. But if you really want to, maybe do this. So the question comes, why? And someone sent me an email that people are sending me notebooks, certain kind of notebooks. And but in those notebooks,
Bending the rules.
In those notebooks, they have a pandas read CSV, and there's no CSV in the email. What do I do? So, well, stop sending emails, right? So, like, stop using notebooks.
Which notebooks?
Share. It's notebook agnostic. So stop using those notebooks, upload them on GitHub or do something, right? And you would ask, really, do people do that? Yes, people do that. And so, well, it's time to show some magic. Right, this is visible.
Fancy environment.
It's a lab interface. And
Also known as.
So let's create some data files. It's some random data, and if we look at this, we have these 2 CSV files. Just some random data, doesn't matter. But let's say that you had another notebook which was reading this data, and by magic, you have You can read this data, and you can just tell me, though, oh, you're just lying. The data files are just there, right? What I'll tell you that, let's delete those files. Whoops, not cut them. Let's delete those files in this Jupyter notebook. And if we run this cell again, the data is still there. It's magic. You can read it as a pandas data frame. You can read it as a NumPy array. It works. And you would ask, how? Why? And the answer is JSON. And so here we are like abusing the essence of the notebook, the JSON format. And you can pretty much just add anything you want in that, right? You should not do this, but as you can see, this project is extremely well maintained. And so please don't use this. So if you have a Jupyter notebook, don't do this. But if you want to, maybe, I don't know. All right, thank you.
Amazing. Thank you. Let's go for a first timer. Luca, why are you here again? You did it already.
Oh, I should have moved.
It's a one again.
I just wanted to why not?
So, the next one. Give me time. I'll get there. Slides. Thank you. So, what is going to be the magic word? Okay. What? Code. Okay. Code is a magic word. Nice. Take it away.
Okay, so what are researchers? I'm going to give us more critique of the code written by researchers. Okay, so it's my only slide. Just move to
What?
one example. I have a project where I have to work on something about gene expression, and everybody knows that epigenomics copy from NLP. So let's say, for example, I search for gene expression and transformer. I will find a bunch of articles. I can take like the first one, for example. Download it, read it, find it very interesting, very math, a lot of experiments. And I want to run the experiments again. So let's try to search for GitHub. And I find a reference here of Keras Beast, and I don't find any code by the researcher. So how can I run the experiments again? I can't, which is a big problem. Then let's say that I go to a better instrument, a better tool, which is Papers with Code. Okay. Where I can find papers with GitHub repository attached to them. Since gene expression is a very niche task, I can search for age estimation, in this case from profile pictures. I can see that there is a benchmark on the data set UTK faces. I can see different approaches, different papers about it. I take the best one on this benchmark. It does have a GitHub repo attached. It does have 63 stars, which is quite a lot for something not famous. But first issue that I see here on the right is that there is no license. So I can't use this code even if I want to. Because if you know a little bit about privacy, not privacy, about licensing, is that if there is no license, the code is copyrighted and no one can legally use it. So everyone should attach some kind of license. And then I can try to look at the project structure, but it's not very clear how can I use this code. There is a README. In the README, there is probably pictures from the paper, some like nice badges for some, because they are always nice. And there are the models to download, which is fine, but there is no documentation to actually use them. And it is, okay, there is some descriptive stuff, but if you know when you use a GPU and you pass parameters, it will never work on your machine. So it's a bit unclear, a bit not very useful, not very reproducible. And this is there is a license, which is for some reason not on GitHub, which is like not a good software engineering approach. But it's not like, there are not few examples of this. It's like 99% of the papers are in this state. They are not actually reproducible. And it is, 68 stars is a lot, but I can go to this one. It has 80 stars. I don't know how exactly what it does, but it's a paper. At least there is a requirement, but there is, again, no license. And it is like this for many papers. If we can look at a good example, if we go to the home page of papers with code, yeah, there is like, the first one is this paper, and with this repository attached, we can see it is from NVIDIA, and it does everything.
Thank you very much. Thank you very much, Marco. We definitely feel your complaints very much indeed. Are you happy with playing with us, Nikita? Yes. Fantastic. Go ahead. Okay, so next one. We have Jonathan Chambers, research to product with Jupyter and Solara. It's volleyball. It's a 3. We don't give justice to Hoven gloves today. So are you going to wear the glasses or say broccoli?
Oh, I am to wear glasses. Scan QR code, by the way, or just describe how you feel. Are you good?
You look cool.
Like, you can shout, how do you feel about the conference and stuff? Yeah? No? Anyone? Well, that's how it goes. I mean, like, if you would open this QR code that I showed you, and again, open it, you can type whatever you want there and how you feel like. Try it. Oh, already 15 responses. Nice. Do more. Do more. I will probably not use all my time, but still. The point of this to show that this presentation is actually running with Reveal MD, which is based on Reveal.js framework for presentations, and this framework is used, I feel like, for everything. Like, for instance, in Jupyter, in Jupyter Lab, if you would try to export your presentation into your Jupyter notebook into presentation, you would get basically a Reveal.js presentation. And here I can embed a bunch of stuff. Wow, broccoli! Yay! So, what's going on? Pythonic, happy, cool, wonderful. And if you tried to click next question, we would see who's first timer here, or second timer, or maybe more. Yeah, the whole thing is just like a couple of lines. It's nothing much. You just go to this Mentimeter. I'm not from Mentimeter, by the way. I just like how it works, and it's free. And I encourage you to try it as well, because in my opinion, it's fun to type something and see it on presentations. Let's see one last time what was going on. 97. Quack. Now quack. Quack. I'm done. Quack.
Of course, entered pineapple, not on the pizza. Definitely not pineapple on pizza. This sort of things. So, do we still have time to play?
I think so. Like,
Fantastic.
we're gonna eat a little bit.
That's okay. Okay, next coming up is Dennis Engelham. That's why you want to roll it here. Told you. It's a 4 in the end. No, it cannot be that. All the mess for nothing. Right. Okay, you're safe. Okay, unless you want to another roll.
It's all right.
Okay.
Enough injury.
I tried.
It's fine. Hi, I'm Jonathan Chambers. I'm wear many hats. I'm a researcher. I'm also co-founder of a spin-off Planeto from University of Geneva. We work a lot in sustainability. I like to address what I call the elephant in the room in sustainable part of the energy transition, which is heating and cooling. Today, more than 60% of CO2 emissions in the building sector come from heating and cooling buildings. Most of that is still coming from oil and gas. For that, we need to build what are called district heating networks. So there's a lot of technical solutions. And as part of our research, we built TESSA, which we call Thermal Energy System Simulation Assistant, which is basically a tool that helps do a lot of GIS analysis, embeds a lot of simulations and so on, to help companies actually develop energy plans. Today I want to talk to you a bit more about the journey that brought us from the research to this product actually, because we started really with a lot of very detailed research in many different aspects of modeling, urban energy modeling, developing ML models for building simulations, thermal networking, temperatures, and so on. And we did this with a fairly classic Jupyter Hub setup. We had the lab, which was super useful. It let us collaborate. If ever, by the way, you want to set up a Jupyter Hub, I wrote a tutorial, which I think got integrated into the official docs, of how to set things up the hard way, by hand. But at some point we thought, well, how would we like to turn all of this kind of back-end mess into a nice product with features, with a user interface, and all sorts of these kinds of things. That's where we found the Jupyter environments and the IPy widgets environment is incredibly useful, and we were able to start to build notebooks that look like this. So yes, you see it's still a notebook, but we can start to use, in this case, Jupyter widgets to start building something that looks like a user interface, that has buttons, that we could start to show partners in industry to say, you know, what do you think? So we're still there as scientists. We don't hire a user interface designer. This was really a team of like 1 or 2 people. And we saw this, and we got such a good feedback on it. We thought, well, do we have to stop using Jupyter widgets if we want to actually build a product around this? This was part of our thinking when we built a startup. And actually, thanks to Martin of Solara, who you might have seen his talk here, we didn't have to. We were able to take this all the way to production, that I can hopefully show you a bit what it looks like. This is actually what it looks like live. This is built with Solara, and not only do we have essentially all the same stuff, animations, it works, we have buttons, it's all live. All of this is written without me as a principal developer writing a single line of JavaScript code, which makes me very happy, because personally I hate JavaScript. And not only do we manage to create, and I won't say recreate, because we really use exactly the same tools, the same widgets. Not only were we able to do that to build this kind of interface with an analytics interface, what people often call dashboards, we actually built all of the website. So when you want to go to projects, when you want to go to basically everything you want, you have really the full site is all built in Jupyter widgets, using all the same tools on the back end, using the same analytics code, with a good performance. This is running on like a micro-sized server, something like that. So I just want to say that today you can actually do this, operate this transition. I think it's really exciting as a scientist to be able to really keep focusing on the science and the research and the development part and still deliver this to people in like a graphical format, in this interactive way, without having to kind of hire like a whole design team, without having to jump into a completely different mode, completely context switching. And that's something which I think is really quite exciting that I wanted to talk about. And if I can get back to my slide, to mention also that we are now a growing team. We're of course also hiring as a new startup, so also come to me if you have an interest in geospatial analytics or just in general Python code. We're open. Thank you very much.
Thank you very much, Jonathan. Okay, now we have Dennis. Are you happy with us playing with you?
Absolutely.
Thank you. It's going to be endless this way. Okay, it's bad. Rema, you're next. Rema, you here? Oh, there you go. Yes. Okay, brilliant.
Anything special? Do I need to wear glasses? I missed the number.
You
Escape?
got a 6. You didn't see it. I'm going to roll it for you again.
Escaper.
The 4. Escape, escape. That's okay. Escape. Nice. Well done.
Okay, let's get started. Yeah, I'm a biomarker and experimental medicine leader working at Roche Pharma in research and development. And, but I'm not going to talk about my work at Roche. Actually, I'm going to share some of my passions that I have as a scientist personally, not necessarily reflecting the interests of my company. And I have a background in EEG research, and I really love analyzing brain signals, and brain signals appear in different shapes and different frequencies. You can measure them with EEG electrodes, and it turns out that one way of being really efficient in building biomarkers and statistical models from brain signals is using Riemannian geometry and making use of the correlation structure of the brain signal in different frequencies. And this can be efficiently solved with existing packages, notably PyRiemann, which implements all of the Riemannian geometry. Nevertheless, a few years ago, when I started working on these topics with my students at INRIA in my previous life in France, we realized that we need a little bit more. And as scientists, we realized how nice it is to have data frames. And we started doing something that seemed apparently a little bit crazy. We started filling the data frames with object array types with covariance matrices. And that sounds lunatic, right? I mean, why would you do that? The reason why you would do that is that you have no interest in interpreting these entries in your covariance matrix, but you think of them semantically. So there is an 8 Hertz covariance matrix, there is a 16 Hertz covariance matrix, and you want to perform some tests on them. You want to implement a permutation algorithm and have some results on how important this 8 Hertz covariance is. And if you have a data frame, you can easily do this, right? Now, okay, so this is what you can do with the coffeein package. So this is a project that is not yet fully released. So this is the master branch. There is release, but you won't find that on the official pip version in the moment. And it gives you an API for going from MNE type of objects. So I'm also a historical core developer of MNE, by the way. Python library for analyzing EEG signals. And what you can do is that with a few lines of code, you can take your input signals, you compute covariances in different frequencies, and you have them ready in a data frame. And now what you need to do if you want to build a scikit-learn compatible model, you need to make sure that you can transform things into tangent spaces and things like this. And Coffeein does all of this for you in one line. So you can make a filter bank model, and you get a pipeline like this that with the column transformer processes all the covariances, computes Riemannian embeddings. Here with Proche common space, for example. Oh, there may be a rank deficiency. You may want to perform PCA before you have a valid tangent space embedding. Then you get your Riemannian tangent space features, and you can concatenate them frequency by frequency and pipe that in a machine learning model.
And that's what you can do with caffeine. Now, if you're interested also in other types of signals, you want to maybe do something where there is a scalar information on drug dosage or cognitive score, and you want to pass it through, and you can also do that. Yes. So let me slow down a little bit. If there is any Polars or Pandas developer in this room, I would be happy to have a beer with you to discuss on what else we could do with the latest advanced developments in coffeine. Yeah, notably, this is all on GitHub. If you want to play with this and contribute, please do it. This is also based, the documentation is based on NB Sphinx. So if you just want to play and you have an algorithm or you have something to show, just make a pull request with a tutorial. And it will be nicely rendered here. Yeah? So here's a basic example of how to build a regression model from EEG inputs.
Thank you very much. So while Remo gets settled, I already picked up a first-time speaker. Okay. We have Zurich meetup. Are you here? Okay. So I guess it's going to be a conference announcement, sort of, right?
And me, what?
You're an organizer. You have to. You're not. You don't get the choice here.
I have no choice, I think.
Exactly. It's a 2. Okay.
I have nothing?
Yes, safe. Let me pick another name for later.
Okay.
It's probably going to be the last for today.
Okay, folks.
Just give me the name.
I'm doing Google Summer of Code since more than 10 years mentoring. And I did this with different projects. And you may have also a scientific project and have not thought about that you can participate. Oh, yeah, I should. Good. And the ideas, you may know, Google Summer of Code is now 18 years. And you can find new contributors here. And the amount of projects and also help us, new programmers from very much different countries join your project. And yeah, if you're a big project, you can get directly, there's also QR code to this program. You can fill out a form there and try to participate. But if you are not well known, this is the most cases for scientific projects, then you have likely no chance because it's not known, your project. But you can also do, because the PSF, the Python Software Foundation, does an umbrella organization, and they have also a selection option. So you can get with your project part of the Python Software Foundation umbrella and get on their ideas page. And then if you have done this step successful, then you get with the whole organization into the program. And for our project, it's a very small project. It's used by a community which does flight planning for atmospheric science, but it's not well known everywhere else. Then this is a page for us, and it looks like this is the ideas page, the QR code to the umbrella organization. You find a lot more projects there. It's also Borg backup, for example, is there, and some others. So you can get with very different projects into the umbrella, and then you have a good chance to find students for your ideas. And this was what we did the last 4 years, some of the projects. And of course, we have also this year 2 students again. And also the students, it's not only from universities, the program rules had changed. It's just everyone over 18 who likes to get into open source. They are now possible to join Google Summer of Code and find a mentoring organization. Yeah, and you also these new contributors, they join a year before this starts your project and fix some stuff and try to contribute and get in contact with you. So, thank you.
Thank you very much. So, are we ready with the next one? Hi, Eduardo, sorry. I'm making a mess with all. Jan Andrik Müller. Sorry for butchering your name. Okay, thank you. I'll get ready for later.
Yeah.
Okay, this is a very safe role. I feel it coming. No. You're spared.
Oh well.
Take it away.
Yeah, I'm gonna be very quick. Hi everyone. I'm here to announce a new meetup in Zurich. So if anyone here is from Switzerland or around Zurich and is interested in open source and of course Python, is very welcome to the meetup. We actually had our first few months ago. That Guillermo team from Scikit-learn came and they brought some issues and we worked together on them. As you can see here, the link to the meetup. The format is basically, there are some open source maintainers that bring a list of issues and we're gonna work on them together. The meetup was actually born in London and we are kind of a sister meetup. What else? Here, this is a very important one. So anyone that is interested, any level, is more than welcome to come. Why would you want to join? To meet new people, because you want to learn, because you want to give back to the community. We have pizza as well that people said is very good. And of course, we are looking for maintainers for the next events. So if any of you is a maintainer and is around Zurich or wants to come to Zurich for an evening, please come talk to me. My name is Eduardo. So anyone join, please. Hi.
Thank you very much. Okay, sadly, this is going to be, please. So you can be spared because you're first-time speaker, but if you want to play...
I play.
Amazing. Huge round of applause, please. Be the witch, not spare you. Okay. Okay, this witch is still on probation. Probably we're going to change tomorrow. Be ready.
Sure. Okay, hi together. I'm Jan Hendrik. I'm having a background in biophysics and I'm from Göttingen. And today I want to talk about Jupyter TL Draw. And my idea was to bring an interactive whiteboard to Python where you can do things on the whiteboard and then this will be reflected in the kernel. And you can do things in the kernel and send it back to the whiteboard. And to get there, that was quite a journey. So you see this little house at the right, that's the Python side. And there somewhere at the left, that's the JavaScript side. And there's this very curvy path, which is the widget cookie cutter, which was the standard till 5-6 months ago. And then somebody came and wrote any widget. That's something like a highway under the mountains built by Travis a few months ago. And that makes widget implementation super, super easy. And today I will show you how this is done with this interactive whiteboard. So this is VS Code, and I click here, and now I have a whiteboard where I can take shapes, I can take arrows, I can take text and things. And I can also control the shape, for example, of the whiteboard with this variable here. And now, the whiteboard is written in React.
Can you make it bigger, please?
Oh yeah, okay, there are some people in the back who want to have it bigger. Nice. Yeah, so it's written in React. So now I can also go to my React component. And so for example, here you see there is no user interface right now, but when I set this one to off, you see it's not saved. Now I save it. And then within 1 millisecond, it's reloading, so it makes it super easy to develop widgets, to not restart the kernel, refresh the page. So I think that's a really big achievement for the widget ecosystem, and I'm really looking forward where this could lead to new widgets based on React, based on Svelte, based on any front-end things that there are.
And yeah, next I will show three examples on where I think interactive whiteboard might be used for. The first one is image segmentation. So here I have a figure, and yeah, here I have other whiteboard, and now, okay, this I don't need anymore. Here I can now, let's select this one here, and I have the stroke. The stroke is sent to Python. Python gets this as a seed, and then the Python calculates here with the watershed method the new image and updates the image in the background. Another idea where this can lead to is matplotlib annotations. So you know it from WhatsApp, when you send a picture to a friend, you can like make some stickers, some nice annotations on this. And the same might be the case when you want to send yeah, some data to a colleague or like to a professor or whoever you're working with, and you want to say, okay, this is interesting. I want to have the focus here, but now some new data came in. I want to update the plot, so I can then like here add another variable, add like another thing, and the plot is updated in the background while keeping the overlay. One last example that I want to show is plotting in this whiteboard. So here I have a wave parcel, which is defined here, and okay, let me restart the kernel. Okay, live demos. It should work. You should see now like an interactive plot here, but that doesn't matter because this is written in as a widget, which can also be deployed with Solara, which we saw before. And yeah, this is the notebook uploaded to Hugging Face, and here I have now the slider. I can slide this thing, and yeah, for example, then I like this view. I want to like adjust this a bit. I want to change the color. I want to change the size, and yeah, but this one still is there, and I can do that as many times as I want, and can build up a really nice visualization just based on Python in the back end, some React in the front end, and yeah, some hosting in the between. And yeah, this project you can find on GitHub. And in case that you're having ideas for what widgets you want to build, I'm there also tomorrow, the day after tomorrow for the sprint. So talk to me, and we can like see where widgets can lead. Thank you.
Thank you so very much. I would like to thank everyone who participated to the talks today, who played with us. Thank you to you, all of you. You've been amazing and actually played better than I was expecting. Thank you so very much. And so this is the last lightning talk. We now have the poster session upstairs. I believe there's still tickets for the social event. The place is really nice, I promise you. It's the same as last year for those of you being here. So I hope to see you there, or otherwise I'll see you tomorrow. Thank you so very much.